I'm Matt. I am from Vancouver, Canada. I am the head of analytics at Materialize. And I guess, yes, I did go to the University of British Columbia. So today I'm going to be talking about some of the real-time analytics work I've been doing over the past year or so. And I think what's interesting about it is that we're part of we have a small data team, a small analytics team. And despite that, we've been doing real-time analytics. And so I'm going to talk about how we've done that. So yeah, as was mentioned, I previously worked at Shopify for 10, 11 years, working mostly on the merchant analytics. So for a Shopify merchant, if they log into the product, the reports and dashboards that they see there, who's visiting their online store, what sales have they had this week, which products are selling well or not. Those were the sorts of things we were building. We had a large team building that. Some of these reports were batch-based reports, some were real-time, but they were all built on Shopify's data platform. Building at the Shopify scale and also with the level of transformation and various things we wanted to do, we couldn't use just kind of, off-the-shelf tools, or at least at the time. And so we were using a lot of Apache tools built into a data platform. So Parquet, Spark, Kafka, Flink, a number of Go microservices, these sorts of things. And so if we wanted to build a new report, and this was largely because of the real-time models, if we wanted to build a new report, it was a very large investment to do so and a long time frame. We weren't able to, like an internal data team might be able to, think of a new report and launch it a few weeks later. That generally wasn't the case, especially with real time. Now, fast forward to today, and I work at Materialize. We're a startup, and we also have real-time use cases that we want to build, but we don't have the same tool set that, the same tools aren't available to us as they were at Shopify. And so, we're kind of left with this question of, well, how can we do that? How can we still do real-time with a small team? So this is our analytics team. It's myself and my colleague, Jonathan.
Does he also live in Canada?
Does he also live in Canada? No, he lives in Boston, I believe.
So he actually exists?
Yes, Jonathan does exist.
Avatar, like your imaginary friend.
No, but Jonathan very much exists. He's shipping code right now. Thank you, Jonathan. And as a small team, we're a fraction of that team at Shopify. And so I think my question generally for everyone is like, if you're in a similar situation and you're wanting to build some real-time data products, do some real-time analytics, and you have a two-person team, how would you do that? What tools would you use? What methods would you take? So over the next 25 minutes or so, I'm going to talk through kind of the journey we've had over the past year. When I joined Materialize about a year ago, our data pipelines were entirely batch. We were running them a few times per day, and the latency was roughly 8 hours. Over the past year, we've lowered that latency, and I'm going to talk about how. Now, I guess jumping to the chase, we used Materialize. And I will talk through how we used our own product and what it is. But it's a little bit awkward for me to talk about the product that my company sells. And so I just want to acknowledge that we are not a sponsor of this conference. And my intention here is not at all to try to sell our software, at least commercially, but I think the ideas behind it and what Materialize does is really interesting and really compelling. And I kind of hope to sell you on those ideas more broadly. The reason I joined Materialize is because of while at Shopify, it was so challenging to build these kinds of reports and analytics that I thought that there must be a better way. And I was compelled to join Materialize because I thought that it was a very promising path to doing so. So I hope to come from that perspective. So real time. Well, the large majority of our analytics within the company aren't real time. They don't need to be. But there are some that are, and I will talk about those. The large majority are the day-to-day metrics, the business reviews, things where we have a dashboard of metrics in Metabase, or we're preparing some Google Slides for a business review. And that is the majority of what we are doing. And for that, we use a very standard stack, and it works decently well. So, we have our cloud data warehouse in the middle. We have our systems of record through Segment and Fivetran into that cloud data warehouse. We then have SQL-based ETL or SQL-based data transformation with dbt. And then we use it in tools like Metabase and HighTouch. So very standard. For those who aren't familiar, and I expect most folks are, but I think it's still helpful to kind of call out, this idea of SQL-based ETL or data transformation, whether it be with dbt or SQL Mesh, I believe that's the other name, the other tool I'm less familiar with. Just want to give it a shout out. Is to have your raw data landed in your data warehouse, and then to have a SQL query kind of like this, create a replace table, purchases, say, with a bunch of logic. And you're basically running that query again and again and again on some sort of cadence, say every 8 hours. And usually you have a large DAG of these. I don't think that comes really as a surprise to anyone here. But it's that core concept that you're really kind of rerunning a SQL query on some sort of cadence that I want to draw attention to. So historical, we have that figured out. It's all working. But there's this other class of workflows that we have within the company that we call our operational workflows, where real time is more important, lower latencies are more important. So this is where we're taking data and doing more of like a reverse ETL kind of workflow, loading data from our data warehouse into other tools, whether that be our authentication tool, FrontEgg. Launch Darkly is kind of where controls which products you have or which features of the product you have access to. PagerDuty for alerting, HubSpot for marketing. There are workflows in each of these that we want to be, that we're not okay being updated only once a day. So for instance, say we have, say one of our field engineers is on a call with a prospective customer and they're interested in trying a new product or a new aspect of the product. Maybe they want to increase a certain limit that we have in place or access a feature that might be still in private preview. We choose to keep the record of those changes and those approvals within Salesforce, bring them into our data warehouse, and then we want to update, say, Launch Darkly, giving that organization access to this new feature. And we want that to happen as quickly as possible. So, say they're on a call, they can do that approval, and the customer or prospective customer can go and see that change right away. So we were building out these operational workflows about 6 months ago, and the existing batch latency of 8 hours wasn't going to be acceptable. But we figured, we were moving pretty quickly. We're a small company, and we said, okay, for the next little while, we think 15 minutes, that's probably going to be okay. So what we did, it happens that as a relatively small company, our dbt or our data warehouse isn't too large, and our the time to build our dbt models isn't that long. And so we're actually able to just start running our dbt models much more frequently in what I'm calling here a hot loop approach. So rather than running our models every 8 hours, we simply started running them every 10 minutes. We also started loading in the data from Fivetran much more frequently, but that's an easy change to make, and suddenly the latency dramatically improved from 8 hours down to about 15 minutes. So a field engineer approves it in Salesforce. Within about 15 minutes, it would appear for the customer. But that came with a price tag. Previously we were using the auto suspend of our cloud data warehouse, and so we were, it was only on a portion of the time, the portion that we were doing that processing. But if we're running the processing all the time, then it's always on. And so, the cost increased by about 10x in order to do this. Not only was it more expensive, but there were also a few additional kind of complexities that we started facing. Nothing too crazy, but definitely annoying and would add complexity into our stack. One was that as part of our running of dbt, we were doing a pip install. installing all the various Python packages we would need. And this had worked totally fine to that point, but now that we were running it 4,000 times a month, it was no longer viable. Like, we were starting to see some random errors. The noise from random failures would start to become quite noisy. We had set it up previously to alert us in Slack, and now, it was just creating some noise. Every couple of days, an error that really we didn't need to know about. Something we could have fixed, but annoying nonetheless. The other another area of complexity that started to appear was orchestration. So as our data sets, we made this change, but then our data sets started to grow. We started to do processing of larger data sets, looking at who's browsing our website, or our AWS logs, like our AWS cost data. And using and building data sets on these increased the amount of time that dbt took to run. And that made this idea of running every 10 minutes or so much less viable than it had been before. So, we started thinking, okay, are we going to need to introduce some sort of orchestrator, run certain jobs at a certain frequency, others at another frequency? Currently, with the current setup, being able to kind of say, this is how fresh the data is broadly across the warehouse is a really nice thing, property. And losing that to have to start dealing with orchestration, it's just kind of another additional piece of complexity. So it wasn't real time, it was more expensive, it was kind of noisy, and now suddenly we're thinking about orchestration with this hot loop. And so, we wanted to get to real time. So how could we do that? Well, maybe we could, figure out the orchestration and the noisiness issues, and we could, run even more hot. We could run every couple of seconds, just our whole data set, maybe. And that's one path where you just drop and rebuild. But as you get to smaller and smaller slices of time, it makes it more and more clear that this is kind of a weird approach that we're taking to ETL. This idea that every time we want to update our data, we drop it and recreate it, no matter what frequency you have in mind. But with us needing real time, this was particularly prevalent. This was something that we faced a lot at Shopify, where it would be really nice just to have a pipeline declared, as a SQL, set of SQL views, be able to deploy that, and for the platform or system to figure it out, to know how to have the data flow in real time through all our various views and just update, to deploy once, and the data would always be up to date. And we had various efforts to try to build a tool that did this, but it's a really hard problem. And 6 months would go by, we wouldn't have a meaningful result, like we had not an internal tool that was ready to really be used, and so we'd have to move on. And so over time, I became familiar with a term for this idea, and it's called incremental view maintenance. It's this idea that you have a materialized view within your database, not a logical one, so like a table, for instance, that you've created based on a SQL query, but where you want the database to keep that view up to date as the data in the upstream tables change. And different databases have implemented this to varying degrees. And I'm not familiar with all the different implementations, but in broad strokes, my understanding is that the implementations of incremental view maintenance in existing data systems, you tend to have a real subset of SQL. So maybe you don't have great support for certain aggregations or joins or subqueries, windows, these sorts of things. Or it's running in sort of quite a micro batch sort of fashion that isn't really intended for real-time use cases, which at least for Shopify was really important, and for us also. But this idea of incremental view maintenance, I think, is really compelling and interesting. And if this is the most vendor-neutral concept, I think, coming out of this talk, that I think we should be considering this a lot more. Now, around that time, a friend introduced me to Materialize. He thought maybe it could be a good fit for Shopify. And I learned more, and Materialize kind of built out as a company ready to launch. And ultimately, what Materialize is a cloud data warehouse designed exactly for incremental view maintenance. So where instead of needing to, if you're especially, and that does so, incremental view maintenance in real time. And so you're able to do, incremental view maintenance in real time. Without, I guess, all the complexities of, say, a stream processor or something like that. So, we're the analytics team at Materialize. No surprise that we eventually started using Materialize as its cloud data warehouse. And what this looked like was, and why it was actually possible for us to do, is that with our existing architecture, we were able to take our existing cloud data warehouse and really just slot in Materialize. Segment and Fivetran could keep writing to Materialize. SQL-based ETL works with Materialize, and Metabase and HighTouch do as well. And so we were able to use our existing workflows that we're familiar with and comfortable with and that were working really well for us to move quickly, but also do it with Materialize. This meant that the latency of our pipelines came down dramatically, from 15 minutes down to seconds. And that was exactly what we were hoping for. And that's, I think, so easy to take for granted, but absolutely awesome, because it avoided so much complexity, which I'll talk about in a couple of minutes. Not only did it kind of achieve that real-time latency that we were looking for, but it also dramatically reduced the costs that we were seeing. We weren't now being wasteful with that hot loop approach, just kind of, using tons of electricity and expensive computers, but we were actually being rather efficient. And so that cost came down, again, back to roughly where we were before. So, we went from 15 minutes down to seconds, but also, cut costs by 90%. That noise issue, that went away because we were no longer running this hot loop that had this flaky characteristic to it. And also, because with Materialize, and I guess I haven't really talked about this, but you deploy your job or your model once, and it's continually kept up to date. You're not, say with DBT, doing DBT run, DBT run, DBT run, that sort of thing. And because of that, the idea of needing an orchestrator, which is triggering these view creations, that goes away, because basically instead of proactively kicking off a rematerialization, the database is reacting to data as it comes in and is taking care of the orchestration problem for you. All right, so that was compared to the hot loop approach. So we were actually able to achieve real time and lots of other secondary benefits. But say that we had been considering stateful stream processing. Maybe it wasn't viable with a team of 2 people, but that's the world that I was coming from Shopify. So these were some of the problems that we were facing at Shopify, which I'll go through, which are taken care of by a tool like Materialize. So I guess the first is the idea of a streaming data lake. You need your streaming data to come in and to be able to consume streaming data, but you also need it archived somewhere. And then when you want to read that data, you need to blend the archived data with the stream data. Now, there's been a lot of advancements in this area over the last couple of years, or even last couple of weeks, to my understanding. But this was a really hard problem for us at Shopify. And using a tool like Materialize, you don't have to think about it whatsoever. It's totally abstracted away. Another similar kind of item was backfills. Stateful stream processors are generally intended for processing the data, the current data, the most up-to-date relevant data, and less so focused on running a backfill over the entirety of time. But with SQL-based ETL, it really is looking at the entirety of time. Stateful stream processors are typically very temporal in nature. You have a lot of time filters in various ways. And that's not for analytics engineers using DBT. That's really not the way that you're thinking about modeling. And that kind of shows itself in these backfills. And so with Materialize, you can just create your view and it just backfills. And the third is that a stateful stream processor isn't a query engine, really. Maybe you could squeeze it in a way where you could use it like that, but especially like some sort of interactive query engine, something that you're going to take Metabase and connect it to or something like that, it's not designed for that. Usually what you would do is take a stateful stream processor and connect it into some other sort of database. And so maybe you're writing into Bigtable, or you're writing into Druid or Pinot or something like that. Whereas with Materialize, that is all encapsulated within the database. And while it might not be evident right at the beginning, there's a lot of complexity that comes into writing those streams of different partitions of a stream processor into a data store and doing asynchronously, and then getting results that are actually consistent. And all of that complexity, again, is all encapsulated within a cloud data warehouse like Materialize. So these are all things that we had to try to figure out at Shopify that, as a team of 2 at Materialize, they're just totally taken care of. So I think in terms of like the broader business impact of using an approach like this, those previous 3 fit into this first one, which is that rather than needing to, if you want to start doing real time, rather than needing to start by figuring out a full data platform with your storage layer and your compute layer and your backfilling and your query layer and consistency and all these things, you can have an integrated tool out of the box. One analogy I heard recently, which kind of resonated, is there's a reason that people choose Snowflake rather than Hadoop. It's a fully integrated tool. And with Hadoop, you often needed, or what you did need, to figure out all the other components. And it's really nice just to have a fully integrated experience. And that's what you get with a cloud data warehouse. The second item there, easy to build. I think I don't have it in the video that I'm about to show, but I can very much show afterwards in the office hours. But the workflow in order to build new pipelines is almost identical to working with any other cloud data warehouse, which is, if you've ever used a stateful stream processor, in my experience, dramatically different and so much faster and easier. You're not thinking about maybe creating a new project or a new jar, Maven, uploading that, waiting for it to start up. It's much more, you create a SQL file, fill out your SQL, dbt run, and 30 seconds later, what have you, that has finished and your data set is ready. And I think that for real time is a dramatic improvement in terms of the workflow. And the third business impact is that it's so much easier to hire. Building a team of data engineers can be really, really hard or even inaccessible. Whereas building a team of analytics engineers is relatively easier. And so I think it's faster to get started. It's faster to just build on a day-to-day basis. And it's also much easier to build the team and probably less expensive to build the team as well. All right, so that's a lot of slides, a lot of talking. But I'm going to show a few examples of things that I've quickly built with Materialize. This isn't so much the workflow of using Materialize. I'm happy to show that afterwards. But hopefully it kind of gives a snapshot of kind of the ease and its really kind of click, click, click kind of nature, similar to maybe a cloud data warehouse. All right. So what I've done is created a Shopify store, and we're going to build a couple different data products, a real-time dashboard to look at the Shopify store, and then afterwards do some reverse ETL. But first, we need to get some data into Materialize. So I have my Shopify store here, and there we go. We're going to use Segment to track all the page views on the online store. So this video goes a little bit quick, but we're going to jump over into Segment and grab the JavaScript tag that they give us in order to track page views. And now we're going to jump into Shopify and put that JavaScript tag into my Shopify theme so that it runs every time a page loads on a Shopify store, or on this Shopify store. And so this is Segment. And if we go and view a couple of pages within the Shopify store, we'll see those events show up in Segment. So now we're capturing some data, and we need to get it into Materialize. So Materialize, one of the ways to get data in is the webhook source. So we're going to create a webhook source. It basically gives this URL, and you can have some authentication on it as well. I just don't have it here to show. And we take that URL, go into Segment, and set up Segment to fire off a webhook for every page view. And this is a very easy thing to do in Segment and great fit for Materialize. The other thing we want is, I'm going to actually just go back slightly. So the other thing we want is our product catalog. So we have our page views and the URL that people are viewing, but we also want to know a bunch of attributes about the products. The name of the product, like t-shirt, rather than the ID that's in the URL, and maybe like that it's clothing versus an accessory, I think is the other one I have in the video. So in order to get the product catalog in, we're going to use Fivetran to get that whole product catalog. And this will also go by pretty quickly. But here's Fivetran. Put in your Cloud Data Warehouse details like normal. And with Fivetran, you can then set the frequency, depending on your plan slightly. But in this case, we set it to a 1-minute frequency. And so if a change is made in the Shopify product catalog, that will update within Materialize. So we now have our page views, and they're updating within less than a second, and our product catalog, which is updating within about a minute. So super easy to get data into the real-time Cloud Data Warehouse. All right, so the next one is the real-time dashboard, I think. Oh, no, that was the same one, sorry. All right, here's the next one. So here's the real-time dashboard. So we're going to browse now. I've created a bunch of DBT models behind the scenes, and I'm happy to show those to you after this in the office hours. But we're going to now browse the Shopify store, and as we do, we'll see this Metabase dashboard that's set to update every 2 seconds, and it'll update with the page views. And so I've created a few DBT models, super simple, what everyone's used to, and I've been able to take the segment page views and the Shopify, or well, in this case, just the segment page views, and the Shopify, just the segment page views, and created a dashboard of page views and sessions in this case. And I created a private browsing tab there to show another session was created. All right, so now we're going to incorporate some other data, that product catalog data. So it's going to flip over in a second. But here I've taken the data from Segment, joined it with the data from Shopify, and now we have a real-time report showing page views by attributes in the product catalog, and it's updating in real time. So there we have pants and t-shirt, and if we go and view the t-shirt, which I think will happen in just a second. There we go. And we're going to view the t-shirt a couple of times, and the page view count increases. And so then, just to show another attribute updating, their product type. So now we'll go see the hat, and that's an accessory, and so we'll see that show up on the real-time dashboard. So this is a very simple example, small data set, but these ideas absolutely scale. And so if you are, say you work at a Shopify store and you are an analytics team, you could build a real-time dashboard like this with exactly the same sort of tools that you're familiar with, just using Materialize as the cloud data warehouse. And I think that's really, really interesting and compelling. All right, okay, yeah, so this is the last demo. And now we're going to have more of an operational workflow. So what we're going to do is we're going to buy the hat. Oh, that wasn't the next one, sorry. Here we go. We're going to buy the hat, but we will have also looked at the t-shirt a number of times. And so we're going to set it up. Behind the scenes, I have a number of DBT models that say, when you buy a product, look at the other products that this visitor had viewed, and send them an email right away with a discount code suggesting that product. So in this case, we have, we're purchasing the hat, and we're going to send them an email for the t-shirt. So we're doing this by taking a Shopify webhook and bringing that into Materialize so that we get that notification in real time. So this works exactly the same way as the segment webhook did. There we go. And when we place the order, that data flows into Materialize, through the DBT models into high touch, and high touch sends off the email. And so those were the emails just sent by Shopify, one because I'm the store owner, one because I'm the customer. And then there's the third one, and this is now that promotional email that was based on a bunch of the page view data within our online store, which I think is that is not an easy thing to build with other tools, and this is super easy to build. So here's a quick view of the DBT models that we have powering this demo. This took me a couple hours probably to put together, I think, definitely in an afternoon. And it has the top products, the donut chart, this email, all these sorts of things with raw data sets, facts and dimensions, and some various kind of report data sets. And this is a very easy way, I think it's very proven, a very easy, good way to build analytics products. And we're able to do that with real time. And this isn't really the way that wasn't really my experience with stateful stream processing. I think this is way more accessible and way more expressive and flexible. All right, home stretch. So SQL-based ETL is as prevalent as ever. Frameworks like DBT are, they've been a huge success. Really democratized analytics as well. Now that's generally used for historical workloads, but there's this class of operational workloads that we've started to see with reverse ETL that can really benefit from real time. However, real time has generally been very inaccessible. It's either taken a huge investment and a huge team, or just not being possible for most companies. But I think that's changing. Incremental view maintenance is emerging as this new technique that's really well suited for processing data, similar, like SQL-based data transformation, similar to DBT, or like DBT, including DBT. And Materialize is one database that implements incremental view maintenance in a really complete, extensive way, but it also happens to do so in real time. And so if you are interested in those real-time use cases, I think it's a really compelling fit. And so I think that creates an opportunity for the ecosystem, where suddenly real-time is way more accessible to most analytics teams. Really, if you're familiar with something like DBT, you're ready to start doing real-time if you'd like to. I think there's far less reason not to now. And I think that also ultimately allows analytics teams to start to get into more operational use cases, which I think can be really compelling. When we talk about the value of data, being able to power these operational use cases, there can be a lot of value there. So, yes, thank you so much for your time. A small plug that if you're interested in trying Materialize, it starts at like 50 cents an hour, even less than that. It's a delight to use. And yeah, thank you.
Thank you, Matt.
Hi. When would you not use Materialize?
So the question was, when would you not use Materialize? And I think the answer today, Materialize focuses on the areas where you have incremental view maintenance, and particularly real-time incremental view maintenance. So if your queries are ad hoc in nature, you're powering something like Tableau, and it's very slice and dice, and every query is different, Materialize is not a good fit. So that's kind of an absolute answer, I think, or at least, it's not optimized for those workloads. There's a little bit more of gray area in how real-time you need your data to be, and if it's worth it versus not. And so I can't really make an exact call there. But if you don't need real-time, but you do need incremental view maintenance, then there probably is some sort of overlap there or some transition point. But if you are needing incremental view maintenance and real-time, then it's a great fit.
Hey, thanks for the talk. You mentioned at some point you were dropping data warehouse for Materialize. Can you clarify how did that step happen? Yeah.
Yeah, for sure. So, how did we just kind of swap it in? And we started with just the data sets that truly needed to be real time. And so currently we're running, both warehouses for different use cases. We did it basically by loading that data, the source data that we needed, into Materialize, and then having a separate DBT project that was focused on those specific models that we were going to have in Materialize. So the current setup that we have is basically a mirror image, pretty much, where data comes into Fivetran and Segment. Some of it goes into Materialize. All of it goes into our existing cloud data warehouse. And then we have 2 different DBT projects, and then pull from there. Happy to chat. Yeah.
Yeah, maybe can we?
So basically, you only have Materialize for the use cases which need to be real time. So it's not for the whole data warehouse.
I think it depends. Currently, that's what we are doing, but we're definitely going to try to use it for everything. But it really depends on the shape of your data. And so I would encourage you, if you're curious, I'd encourage you just to give it a try and see how it fits for your data set.